The contractor's suggestion is not valid. UL 514 requires metallic enclosures for weatherproof applications, whereas IEC 669-1 covers rigid plastic enclosures which do not meet the specific requirement of UL 514A. IEC 669-1 is an international standard published by the International Electrotechnical Commission. It stands for Enclosure Systems for Electrical Equipment. Within that designation, the E refers to enclosures used to house electrical equipment. The C indicates the level of protection provided by the enclosures against external influences like dust and water. The number 66 identifies the series of standards related to enclosures. The number 9 denotes the specific part of the series covering general requirements and tests for enclosures. Finally, the -1 indicates the first part of the standard. To further elaborate, let's delve deeper into each of these standards individually. UL 514A, published by Underwriters Laboratories, is the standard for safety for metallic outlet boxes. This standard specifically outlines the requirements for metallic outlet boxes, conduit boxes, and fittings for use in electrical systems. The primary focus of UL 514 is to ensure that these metallic enclosures provide adequate mechanical strength, electrical grounding, and protection against environmental factors such as corrosion and moisture. It mandates specific construction requirements, including material thickness, corrosion resistance, and the integrity of enclosure openings. The standard also includes rigorous testing procedures to verify the enclosure's ability to withstand various conditions such as impact, vibration, and exposure to moisture. The requirements within UL 514 are critical for ensuring the safety and reliability of electrical installations, particularly in demanding environments where enclosures are subjected to harsh conditions. In contrast, IEC 669-1, developed by the International Electrotechnical Commission, addresses switches for household and similar fixed electrical installations. While the standard covers a broad range of requirements for switches, including electrical endurance, mechanical strength, and temperature rise, it does not specifically focus on the requirements for enclosures in weatherproof applications. The I-54 rating, often associated with IEC 669-1, indicates that the enclosure is protected against dust ingress and splashing water. However, it does not provide the same level of protection as a metallic enclosure complying with UL 514A, which is designed to withstand more severe environmental conditions such as heavy rain, snow, and ice. The fundamental difference between these standards lies in their scope and intended application. UL 514 is specifically tailored for metallic enclosures used in electrical systems, emphasizing robustness and protection against a wide range of environmental factors. IEC 669-1, on the other hand, focuses on the performance and safety of switches, with enclosure protection being only one aspect of the overall standard. Therefore, when selecting an enclosure for a weatherproof application, it is crucial to consider the specific requirements of the installation environment and choose an enclosure that complies with the appropriate standard. In many jurisdictions, electrical codes and regulations mandate the use of UL-listed equipment for certain applications, including weatherproof enclosures. This is because UL listing signifies that the equipment has been tested and certified to meet the safety requirements of the applicable standard. Using an enclosure that does not comply with UL 514 in a situation where it is required could result in code violations, safety hazards, and potential liability issues. The NEC, or National Electrical Code, is a widely adopted standard for electrical installations in the United States. The NEC provides specific guidelines for the selection and installation of electrical equipment, including enclosures. It often references UL standards such as UL 514A to ensure that equipment used in electrical systems meets minimum safety requirements. In the context of weatherproof enclosures, the NEC typically requires that enclosures installed in wet or damp locations be listed for that purpose. This means that the enclosures must be tested and certified to comply with a recognized standard, such as UL 514A, to ensure that they provide adequate protection against moisture and corrosion. Failure to comply with NEC requirements can result in electrical code violations, which can lead to fines, project delays, and even legal action. Therefore, it is essential for electrical contractors and installers to be familiar with the NEC and to select equipment that meets its requirements. Moreover, the selection of an appropriate enclosure depends on the specific environmental conditions present at the installation site. For example, in areas subject to frequent rainfall or high humidity, a weatherproof enclosure is necessary to protect electrical components from moisture damage. Similarly, in industrial environments where equipment is exposed to corrosive chemicals or extreme temperatures, a specialized enclosure with enhanced protection features may be required. The IP rating system, defined in IEC 60529, provides a standardized way to classify the degree of protection provided by enclosures against solid objects and liquids. The IP rating consists of 2 digits, the first indicating the level of protection against solid objects and the second indicating the level of protection against liquids. For example, an I65 enclosure is dust-tight and protected against water jets, while an I67 enclosure is dust-tight and protected against temporary immersion in water. When selecting an enclosure, it is important to consider the IP rating in relation to the specific environmental conditions at the installation site. A higher IP rating indicates a greater level of protection, but it may also come at a higher cost. Therefore, it is necessary to strike a balance between the level of protection required and the budget available. In addition to UL and IEC standards, NEMA, or the National Electrical Manufacturers Association, also publishes standards for electrical enclosures. NEMA standards provide detailed specifications for the construction, performance, and testing of enclosures, and they are widely used in North America. NEMA enclosures are classified by type, with each type providing a different level of protection against environmental factors such as dust, water, and corrosion. For example, an NEMA 3R enclosure is intended for outdoor use and provides protection against rain, sleet, and snow, while a NEMA 4 enclosure is watertight and dust-tight, making it suitable for use in environments where equipment is subject to frequent washdowns. When selecting a NEMA enclosure, it is important to consider the specific environmental conditions at the installation site and choose an enclosure type that provides adequate protection. The choice between metallic and non-metallic enclosures depends on several factors, including the application, the environment, and the applicable standards and regulations. Metallic enclosures, such as those made of steel or aluminum, offer superior mechanical strength, impact resistance, and electromagnetic shielding compared to non-metallic enclosures. They are also more resistant to extreme temperatures and corrosive chemicals. However, metallic enclosures are typically heavier and more expensive than non-metallic enclosures, and they may be susceptible to corrosion if not properly coated or treated. Non-metallic enclosures, such as those made of plastic or fiberglass, are lightweight, corrosion-resistant, and relatively inexpensive. They are also non-conductive, which can reduce the risk of electric shock. However, non-metallic enclosures are generally less robust than metallic enclosures, and they may not be suitable for applications where high mechanical strength or electromagnetic shielding is required. In addition to the enclosure itself, it is important to consider the accessories and fittings used to complete the installation. These include items such as conduit fittings, connectors, bushings, and sealing washers. The accessories and fittings should be compatible with the enclosure and should provide the same level of protection against environmental factors. For example, when installing a weatherproof enclosure, it is important to use weatherproof conduit fittings and sealing washers to prevent moisture from entering the enclosure through conduit openings. Similarly, when installing an enclosure in a corrosive environment, it is important to use corrosion-resistant fittings and hardware. Proper installation practices are essential for ensuring the long-term performance and reliability of electrical enclosures. This includes following the manufacturer's instructions, using appropriate tools and techniques, and taking precautions to prevent damage to the enclosure or its components. It is also important to inspect the enclosure regularly for signs of wear, damage, or corrosion and to take corrective action as needed. Proper maintenance can help to extend the life of the enclosure and to prevent costly repairs or replacements. In summary, the selection of an appropriate enclosure for a given application requires careful consideration of several factors, including the environmental conditions, the applicable standards and regulations, the type of equipment being housed, and the budget available. By taking these factors into account and following best practices for installation and maintenance, it is possible to ensure the safety, reliability, and long-term performance of electrical systems. Firstly, consider the environment. Secondly, examine relevant standards. Thirdly, think about the equipment that you will house. The environment plays a crucial role in the selection process. Factors such as temperature, humidity, exposure to chemicals, and the presence of dust or water can significantly impact the performance and longevity of an enclosure. For instance, in coastal areas with high salt content in the air, corrosion-resistant materials are essential to prevent degradation of the enclosure. Similarly, in areas prone to extreme temperatures, enclosures must be able to withstand both high and low temperatures without compromising their structural integrity or the performance of the electrical components inside. The relevant standards and regulations provide guidelines for the design, construction, and testing of electrical enclosures. These standards are developed by organizations such as UL, IEC, and NEMA, and they are intended to ensure the safety and reliability of electrical equipment. Compliance with these standards is often required by local electrical codes and regulations, and it is essential for ensuring that the enclosure meets minimum safety requirements. The type of equipment being housed within the enclosure also influences the selection process. Different types of equipment have different requirements for enclosure size, ventilation, and access. For example, enclosures housing heat-generating equipment may require ventilation to prevent overheating, while enclosures housing sensitive electronic components may require shielding to protect against electromagnetic interference. The budget available for the enclosure is also a factor to consider. Enclosures range in price from relatively inexpensive plastic enclosures to more costly metallic enclosures with specialized features. While it is important to select an enclosure that meets the required performance and safety standards, it is also necessary to consider the cost and to choose an enclosure that fits within the available budget. Finally, consider the IP rating, or ingress protection rating, that is designed to classify how well the enclosure can keep the items inside safe from solids or liquid intrusion.